Hello, everyone. My name is Shannon Prather, the marketing cultivator at GIS Inc. I'll be your moderator today, and I'd like to thank you all for joining us for today's webinar entitled Esri's GeoEvent Server, Real-Time Impact for Techs and Execs. GIS Inc. is proud to be part of Esri's partner network, and as an Esri Platinum partner, today's presentation will explain Esri's GeoEvent Server is, where it lives in Esri's platform, how to leverage it for your specific business or agency needs. We'll cover the part sensors play in connecting GeoEvent, integration opportunities, use cases, and more. During the webinar, we'll pause for a moment to ask 2 polling questions and get a pulse on the audience's priorities. I would encourage you to post questions throughout the webinar. We're going to respond to all questions at the end as time allows. After we answer questions and provide some closing statements, there'll be a brief survey. The survey will show up on the screen after I've finished speaking. We realize you'll want to get back to your day at hand, but please do not hit the close button until you have seen the survey questions appear on your screen. Your time to answer these short survey questions is greatly appreciated. This webinar is being recorded and will be posted online. You'll receive a link to the recording via email within a week. GIS Inc. has solved where problems geospatially for over 28 years. With 160 professionals and one core purpose to create insight through location technology, we help state and local and federal governments, as well as commercial industries, improve operational efficiencies, increase citizen engagement, optimize investments in Esri's ArcGIS platform, and increase revenues. But without further delay, I'm excited to welcome our presenter today, Steve Mulberry, Senior Solution Architect and Sales Engineer at GIS Inc. Steve Mulberry currently serves as the Senior Enterprise Architect and Sales Engineer at Geographic Information Services Incorporated. Steve has over 28 years experience in GIS, creating and architecting enterprise systems. He started his career in the United States Marine Corps as a cartographer and terrain analyst, and since finishing his commitment, Steve has been employed by both state and local governments as well as private GIS consulting firms such as Esri, where he spent 11 years as a solution engineer. More recently, Steve has focused his attention on IoT and sensor-based technology and helping organizations find real value in implementing workflows to help improve efficiencies both indoors and outdoors. Steve's going to get it started today. I hope you enjoy the webinar. Steve?
All right, thank you so much, Shannon. I want to welcome everybody into the new year, 2019. We at GIS Inc. are really excited about this year and about this topic. We feel that 2019 is going to bring a lot of excitement around this whole sensor-based Internet of Things, WorkSmarter concept, and we want to start off the new year right by kind of introducing the components that you guys can use throughout the year here to look at ways for ingesting those observation data, those real-time feeds and things like that. So we're going to go through these topics today. We're going to look at and talk about real-time data, what that really means, and kind of break that down into different categories. We're going to look at some key capabilities of GeoEvent and where you can get the most out of the software. We're going to look at GeoEvent in context of ArcGIS Enterprise. Where does it fit in that environment? And then I'm going to break every webinar rule here. I actually want to walk through a couple live examples to kind of show you how to ingest real-time data in 2 different styles here. So we'll take our chances and we'll work through those examples. And then we'll kind of back up and look at some other use cases, some other integration options we have, and then finalize on how can you get started, right? What do you need to have in place to get this thing up and running? So let's get started. We've got a lot to talk about and some really good demos to kind of walk through here. So as we get started, we'd like to ask a quick polling question to kind of get a pulse of the audience. So I'm going to turn it back over to Shannon real quick to kick this off.
Thanks, Steve. So we wanted to poll the audience. What is your relationship status with GeoEvent? Options are we have GeoEvent and we are using it. We have GeoEvent, but we're not yet using it. Or maybe you don't have GeoEvent.
So I think it's important to kind of help us understand sort of the uses out there with GeoEvent now, because we might help me tailor some of the discussion around when and where to use it, and at what point in time to implement this inside your organization.
Awesome, and thank you all for who participated. We're going to close the poll now and launch those results.
All right. Yeah, I'm interested to see what the status here is. So quite a few of you do not have GeoEvent yet, but it looks like almost 50% have it. Maybe some of you are using it and not even using it yet. So this is great. This is really good. This is going to give us some insight on how to kind of talk through the server role, the components, and how to best use them. So let's get started here. So let's talk about real-time observations and the data that supports these types of observations. We're gonna break these down into three categories. We're gonna start off with things that are stationary, right? These are sensors or IoT devices that are stationary but are gathering important information. Things like stream gauge sensors that are measuring the height of water as it flows underneath critical infrastructure bridges or things like that, or any type of environmental sensors. Things that are measuring air quality, noise pollution, those kinds of things. Sensors that are static, that are monitoring events at that location. Any type of transportation type sensors. We see a lot of need for monitoring bridges and the infrastructure required to support them, like vibration or temperature, surface temperature, or weight of vehicles, right? So these sensors, or the count of vehicles across a certain pavement section, right? So those things are sensors that are stationary but are bringing back really good information. Building management systems, the same thing, controlling the heating and air conditioning, the occupancy, the turning lights on and off, and those kinds of things. These are all sensors that are stationary but are gathering vital information that we need to react upon. So think of data in that category, things that are stationary but give us really good information. And then things that move, right? Vehicles, maybe we're tracking our first responders. We've got delivery vehicles. We've got animals that we want to track. We're looking at weather, specifically things that we can track like hurricanes. We can track the movement across time. People fall into this category. Assets, maybe we want to track our assets within a building, like maybe laptops or any other type of assets that we want to track. Those things fall into this category of things that move, right? Things that could go from one spot to another spot, sensors built into them, gathering information, but we want to track their movement across time and space. And then there's things that are event driven or things that just happen, right? Things like crime, lightning strikes. Social media falls into this category. Those of you that have implemented GeoEvent maybe have done the Waze integration, right? Those are things that just happen. And we see a lot of opportunity leveraging GeoEvent to process these types of information. And more particularly, I want to kind of shout out to Dave Ray out in Roanoke, where he's using GeoEvent to actually track dispatch error. So as an event comes in at dispatch, a geocode, an address is matched. If it's bad, we need to know about that. So GeoEvent can actually monitor that information and then react upon that and alert and figure out why. So think of GeoEvent as not just of processing spatial information or things that are tied to a location, but it can be listening to data, event-driven data, and then react upon that. So what I like to do is just kind of jump out and take a few moments here and kind of show you some examples of using the operations dashboard to look at things that are stationary, things that are moving, and things that are event-driven. So let me jump over here to my web browser. And this first example, very simple little dashboard that's showing me a stream gauge monitor that's tracking the height of the stream gauge underneath this particular bridge here. And it's giving me a simple gauge and a simple legend that gives me the current distance between the underside of that bridge and the water. And in fact, this dashboard is going to be one of the demonstrations that show you how to build from scratch when we get to that point. So this is that concept of stationary, right? This thing's stationary, but give me some vital information. I'm clicking on the information and I'm using it now visually, but I can also use it to send triggers or send alerts when the water gets to a certain height. Here's another example of tracking real-time vehicles. This is a snowplow monitoring example in Colorado, where we're tracking right now active 3 trucks that are active, their average speed. It shows their percent complete, and you saw one just dropped off, so they completed their route, and the other 2 are still in progress. We've also integrated social media. So here's an example of something moving, and something that's event driven. So this one snow cloud must have bumped into a car, and the resident on social media sent in a message to kind of alert, what's happening there. So seeing a combination of both things that are happening here. Again, GeoEvent is being used to grab that information in and then display that and use that. Then finally, we talked about David Array over at Roanoke County. He's using GeoEvent again to monitor those dispatch errors as they come in, and then using a dashboard in this example to highlight and show and monitor those bad addresses or those bad dispatches, and then allow the right people to interact and work the problem to fix and figure out why they might have some bad dispatching. So a couple quick examples of looking at things that might be stationary, things that don't move, things that move, and things that are event driven. And that's kind of how you want to approach looking at GeoEvent. When you start looking at ways to ingest data in your organization, start to define what that data looks like, where is it coming from, where does it fall into this pattern. So let's look at the capabilities of GeoEvent and where we can leverage these capabilities as we're working within our realm and our data that we're concerned with and those observations. And I ask you, as you kind of think through this, think of not just things that happen outdoors, but things that happen indoors. So one of the key capabilities is to ingest data inside GeoEvent. And so there's these things called input connectors, and they're configurable inputs to where I can configure the data feeds that are coming in from all kinds of sources, different sources. It could be IoT sources, vehicle, animal, stationary sensors, people, assets, water meters, weather. It could be just about any type of element or piece of information that we want to monitor in a real-time mode. And you configure those through these things called input connectors. Okay. The next capability is be able to real-time analyze that information. So as you configure this input of data, you're ingesting this information. I want to be able to ask some questions, maybe filter it, maybe create some spatial relationships, or process that data further, maybe geo-enrich that data before I push it out. And so GeoEvent gives us the ability to do real-time analytics. And one of those is being able to attribute filters. We are seeing, especially in the IoT space, lots of information being streamed into GeoEvent, and we want to make sure that we can first get just the relevant data. So in this example, we might set a filter in GeoEvent to say, hey, only let the round orange things through. Everything else I don't want to deal with right now. All right, and so just process the information that we're after. Then once I get that information, I can apply some spatial filters to that information. Maybe I want to check to see if that thing that I'm tracking, that asset or that vehicle or that person, whatever it might be, are they within this geofence that I set up? Or are they outside that geofence? Did they enter or did they exit? Right? Is this weather front coming into my city? When is it going to impact? How long will it be in my space? When does it cross a certain area? So there's lots of spatial operators, about 12 of them that we can use to further analyze the information as it's coming in. Now, once that information is coming in and I'm providing any kind of spatial operator, and don't think of just polygons. We can work with points, lines, or polygons in this spatial context. But I may further want to use that information and provide these processors to allow me to extend the way I work with information. So maybe I want to take a dot that represents a delivery vehicle, and as it's driving down the road, I want to create a buffer around that shows me its possible drive time based on the fuel that's still in the tank. Or maybe I'm dealing with electrical vehicles. How far can I drive in any one distance given the current charge within my battery? Those are the kinds of things that you can apply in real time to the data as it's coming in. So you have these data ingestions through configurable inputs. You have real-time analytics. And then we have the capability of storing and visualizing that information. And there's a couple ways we can do this. We can push that data straight out into an enterprise geo database inside the spatial temporal big data store. We can create stream service that allow us to visualize that information in real time. We can push this data to other systems that you'll see me do this here during the example. So lots of ways for us to store the information, retrieve that, and then visualize that back out into maps and apps and solutions. There's also, a part of its configurable outputs, these output connectors, we can notify, we can send emails or text messages or push information to other systems. So we might, as information is coming in, we might want to notify a field crew of a new service request or alert a system administrator that it's getting too hot in the service room because of sensors detecting heat. So those kinds of things can be used. We have these configurable outputs that allow us to store the information, send out notifications, and work the problem as the data is coming through. And then finally, I want to kind of highlight that GeoEvent is IoT ready, meaning that it's a RESTful environment. So I can bring data in through REST interfaces and REST protocols, or I can also push information out. So maybe I'm grabbing the location of my delivery vehicle, right, that spatial context, and I'm tracking that in real time. I have geofences placed around my delivery yards or my delivery depots. And maybe I have other IoT systems in place that maybe unlock the front gate, right? Or trigger lights to come on automatically for me when I get into a certain proximity. So I can set up these geofences that say, track that vehicle. And when it gets to a certain space, let GeoEvent then push information out over to other IoT environments like Azure or Amazon Web Services, and then trigger action against other devices, right? So it can communicate within itself and with other systems, other business systems, other IoT systems. It's open and compatible to be part of that enterprise environment there. So I just kind of brushed on some of these capabilities. If you want to learn more about that, I'm going to show you where to find it. There's a GeoEvent server webpage that you all can visit and look at. And here's sort of the interface of it. It's just enterprise.arcgis.com/GeoEvent, and it'll take you here. And I'm going to kind of just show you a couple examples real quick. So I'm going to click on getting started with connecting with real-time data. So here's our input connectors, right? Here's our output connectors, and here's what we do with the data in between. Okay, it's pretty straightforward. So let me click on learning about input connectors, and I'm going to jump right to the input connector section. And you'll see that's got a lot of examples of how you can ingest that data from files, from RSS feeds, from web services, from web sockets. There's a whole gallery of additional input connectors for connecting to things like Waze and Verizon and FlightAware and all these other industry standard data feed components. And then there's business partners that are also creating additional input connectors. So it's really getting to the point where GeoEvent is really allowing me to connect to just about any kind of information feed that I want to bring in to GeoEvent, so then I can process and work with it outside. So take advantage of that website. There's lots of good information out there. So let's look at GeoEvent in context of ArcGIS Enterprise. So from a simple diagram standpoint, these are the components of ArcGIS Enterprise. We should be somewhat familiar with this now. This has been in place since 10.5 release of ArcGIS. And so we have the adapter, we have portal, we have server, we have data store. These are the base components. In order to now work with real-time data and observation information, we have to add in the GeoEvent server. This becomes a server role component. And there's several other of these components out there. There's GeoAnalytics, and there's some other ones that extend the capability of enterprise. So in order to kind of do the things that I'm going to show and talk about today, you'll need to have GeoEvent server as part of your enterprise deployment pattern. So what does that deployment pattern look like? So I'm going to get technical here just for a second, because I want to kind of show you how that fits into the enterprise. So typically, this is how a base deployment looks like. We have our portal, our hosting server, our data store, and the web adapters help us with security and federation, right? And if you look at this from the deployment pattern, this becomes our web server, this becomes our GIS tier, and this becomes our data store tier. And these components combined then make up our enterprise web GIS tier. You probably heard that term before. This gives us the ability to bring GIS to the web and support all of our web initiatives. Now, most organizations put in place an on-premise or an organizational level ArcGIS server with an enterprise geodatabase, and this tier becomes our enterprise GIS. This allows us to do our day-to-day work, collecting information, managing our authoritative data, and then supporting the web tier. So where does GeoEvent sit? It sits as an additional service and brings us into the enterprise IoT tier level. So with GeoEvent, you get the spatial temporal big data store, which allows us to store the information in large amounts of information in an environment that allows us to analyze and retrieve and visualize that information very quickly. And over the releases, GeoEvent has been able to improve the way it ingests information. So right now, sitting at 10.6, you can expect to ingest around 6,000 events per second. So depending on the order of magnitude of the data that you're working with, the information that you want to ingest, you could take that information and push it right into the big data store. You can also, as we mentioned, store information inside of the enterprise geodatabase, but keep in mind that the order of magnitude really dictates where we push that information and how we process that data. So this is just a quick overview of a typical deployment pattern for your enterprise environment to create a web presence, a GIS presence, and an IoT presence within your environment there. So enough of that. I want to get into and show some examples here. This is where I'm going to break the rules, but I want to do a live presentation. I want to show you how this kind of works, how all the pieces come together, and we're going to start from scratch, and we're going to bring in this first example, we're going to bring in an AVL feed. We're going to track vehicles in real time. So I'm going to connect to a feed that already exists out there. I'm going to create an input connector into GeoEvent, and I'm going to do some visualization. So it's basically just 3 steps. Configure an input, configure an output, and then connect those inputs and outputs through a thing called a GeoEvent service. And inside this GeoEvent service, I could extend the capabilities. I could process information. I could do my real-time analytics. That's where I can perform additional processes against that information. And then my final step is just create a web map, configure that, and point to the service that we just brought in. So let's go back out here to my web browser. And I'm going to close a couple of these tabs I don't no longer need. All right, so we're going to start right here. So here's a URL that gives me access to all of the MARTA buses in the Atlanta area. So those of you familiar with that area, they have a MARTA, which provides bus transit throughout the entire metro Atlanta area. And they provide a JSON feed of that information. And this is how it looks in its raw form. All right, so I'm going to take this information, and my goal is to get this raw data into the platform so I can see dots moving around on the map. Okay, so the first thing I need to do is I need to create that input connector. So what I'm going to do is come over here to my GeoEvent manager. So this is GeoEvent. This is what the manager looks like, and I can monitor my services, my inputs, and my outputs. And I got quite a few of them in here. But I'm going to start off with the inputs. So I need to configure an input to ingest that data. So over here, I do add input, and I know that's a JSON web service that's coming in. So I simply start typing in JSON, and it gives me a list of all of the compatible input connectors that relate to or work with JSON. So we can see here, we can say, I need to pull an external website for JSON. That's perfect. That's just what I need to do. I need to hit a URL that's giving me all that information. All right, but there's other options here for processing JSON data, quite a few. So I'm going to select this one right here. And when it comes up, it's going to ask me just a couple questions. First off, what I want to name it. And typically I like to keep a consistent naming convention so I can keep track of my inputs, my outputs, my services, and things that I'm working with. So I'm going to call it MARTA underscore. I'm going to leave everything else the same. And here it's asking me to provide that URL. So I'm going to jump back here to this browser, grab this URL, and bring this into this input connector. Now, the next part here is really important. So if we go back here, we can see here's the definition of all the data coming in from that stream, right? And this could change over time, but right now, this is what it looks like. And I see I have a latitude and longitude, I have a timestamp, and I have a unique ID. Those are the most important things that I need in the feed. Lat long, timestamp, and the unique ID. Other information is very important because it tells me the status and other things, but those 3 things are most important. And so the next step here in creating this input connector is defining the metadata. GeoEvent calls it a GeoEvent definition, but it's really the metadata behind that stream. And so I want GeoEvent to create this for me automatically. So I'm just going to go ahead and create a name for this. I'm going to call it MARTA raw. So this is the raw data that's going to come through with this event. Now, a couple of last minute things here. I'm going to get the data under the advanced tab. I know that I have lat and longs coming in. So I'm going to have GeoEvent, this input connector, construct geometry for me automatically. So I don't have to do that after the fact. So basically all I do is come in here and find the latitude and longitude field. And let's put that in here. So let's put longitude here, because I know those are the fields that are coming out of the raw data, and latitude in the Y field. So when that information comes in, GeoEvent's going to take that data and create a geometry field for me automatically. I won't have to mess with that. And then one last thing I want to show you here. It's going to read that information every 5 seconds. Maybe I don't need it that frequent. Maybe I need it 30 seconds or later, or even down to 1 second. And then down at the very bottom, I want to point out this one. So there's a learning mode that's attached to this input connector that allows me to learn. So if the data does change, that's okay, right? GeoEvent's going to recognize that, update my definition and my metadata, and allow me to continue to move on here. So that's real important. So we've got our input connector. I'm going to hit save. It's going to validate everything. Got my name, my URL, my definition name, my longitude and latitude. Make sure everything's set up there, and I'm going to hit save. So this is creating my input connector. And so we can see it right here, my new input connector. So now I need to create an output connector, and I want to do something that I typically do just to test the system out, just to make sure it's working right. So I'm going to jump over here to my outputs, and I'm going to create a new output connector. So I hit add output, and here I'm going to create a WebSocket. So I'm going to start typing in WebSocket, and you'll see it quickly filters down to the options that I can have as an output connector from a WebSocket standpoint. And here I'm going to pick this last one here because I just want to do a generic JSON out. So my goal here is to make sure that I can get data in from that JSON URL stream, and I want to make sure GeoEvent gets it, and I want to make sure it's pushing it out so I can see it, right? So this is my test to make sure it's working. So I'm going to select this. Again, using same conventions here, so I keep everything intact. Then finally, it's asking me what I want to call this URL. So I'm going to call it a WebSocket, call it MARTA. So WebSocket MARTA. This gives me the ability to then hit it from a web page, and I can test to see if data is really coming through. There's only one option here under advanced. We'll just leave this alone for now, and I'll hit save. So now I've got my input connector, I've got my output connector, my test is just a test to make sure I'm getting data in and out. The next step is to connect those two together. And we do that through a GeoEvent services. So I'm going to come over here to a GeoEvent service. I'm going to create a new service, and I'm going to call it MARTA_ABL. So again, I can keep things in sync with me. If I want to put a description, I can. And this brings up sort of this drag and drop approach where I can drag the elements that I want to use inside of this process. So I've got my input right here, my MARTA input. This is that JSON URL pool. And then I've got my output where I've got my MARTA WebSocket out. So I'm going to literally just dragging and dropping, and then I'm connecting the two together. So I want everything from here to go to here. I'm going to publish this. And as soon as I publish it, we should start seeing every 5 seconds information coming through. So we can see immediately I'm getting data. I'm getting data in and I'm getting data out. So I know that at least that part's working. So I'm ingesting data and I'm pushing it back out. But I want to validate, right? I want to make sure that's the right data. So I'm going to come over and I'm going to create a new web page here real quick, and I'm going to hit that endpoint. So I'm going to hit that WebSocket that I just created, coming from GeoEvent. I'm going to connect to it, and I'm going to look at the data coming across there. So here we go. Here's all the data coming across. I'm going to disconnect real quick because it's lots of information. But there's one thing I want to point out to you. So this constitutes one record right there. This is all the information coming from that original JSON feed. But what GeoEvent did for me in the mix, because I said, create geometry for me automatically, it added this component to the end of that stream. So it now knows it has a spatial element and the spatial reference for me automatically. I didn't have to do anything with it. And now I can use that information to put dots on a map. Okay. So we've got the input coming in, we've got the output, we've tested it, everything looks good. Now there's one thing I need to do to make sure this works from a visualization standpoint. So let's go back to my GeoEvent manager, and I'm going to come over here to the site configuration. And I'm going to show you that metadata that was created. So here's that MARTA raw definition, that geodefinition that was created for me. And if I hit the edit button here, you'll see that by default, it found the timestamp and it created the geometry for me. The only thing I need to do here is to identify that unique ID. Remember, I said there was 3 things we need. We need a timestamp, we need geometry, and we need a unique ID. So I'm going to grab the vehicle field, and I'm going to set its track ID to the vehicle field. And now I'm going to save this. So now I've updated the data as it's coming in to now know those 3 main components. So now I can do just about anything I want to do with it. I can display it, I can analyze it, I can process that information, I can do lots with it. So let's go back to services. Let's go over to the output. Let's create one more output because now I want to see that information. So now I'm going to create a stream service. So I'm going to start typing in stream here. And there's one option that allows me to stream that information right back out. So I'm bringing in the raw data. I want to stream it back out so I can see dots on the map. So I'm going to hit select. And I'm just going to go through the process of, again, naming this service that I want to create. We'll call it MARTA again. I'm going to connect to my metadata, right? That geodefinition. I'm going to connect to the server to where I want to publish this. So this is why ArcGIS Enterprise is important, because we have to have that server element. I'm just going to put it at the root. Then I'm going to publish a new stream service. So here we're going to call it MARTA Stream over on GIS on my server component. I'm going to leave all this data default except for, I want to pick, in this case, my vehicle ID. So that's going to be my default display. If I click on the point, I want to see the vehicle ID as the default display. And then I hit publish. Now at this point, it'll take just a few seconds here. Let's kind of review what's happened so far. So we identified our raw data, the information, that feed, that AVL feed that we want to ingest, and we realized it's a JSON feed. We created an input connector inside of GeoEvent to ingest that data. I temporarily created this quick little WebSocket output connector so I could test and make sure, yes, I'm getting the data, it's coming through, it looks good. Then I set my track ID, my unique ID. Once all that's in place, then I created the stream service, which then allows me to visualize that information. So if I go back into my GeoEvent services, go into my MARTA AVL service that I created that input connected, that input and output connector to, I should have a new output for that stream service. And here's that stream service. We'll drag and drop that over. Again, just connect the 2 things together, republish. And what's interesting you'll see here is now I'll get 1 set in, but 2 sets out because it's going to my WebSocket and it's going to my stream service. Great, we're set. Now, all I need to do then is go over to my portal. So let's jump over here to my portal interface, jump right to the mapping component, and let's add in now that stream service. So here we'll say add data, we'll search for layers, we'll type in MARTA, we'll search everywhere. There's that stream service, we'll add it to the map. It's adding it in, I'll say done. So every 5 seconds, it's going to start to display. It might take a few seconds here, but now you can see dots starting to display. And what's interesting is, whoa, wait a minute. We're seeing some anomalies here. There is some bad data coming in from that JSON. There's probably some switched X and Ys. That's okay. I got the raw data right here. We're going to zoom in to the Atlanta area, and we'll see every 5 seconds, we'll get a new feed, and you'll see that data start to come across. Okay, now there's lots of things I can do here. I can change the streaming controls. I can work with my symbology. I can put a tail or a trail behind the vehicles. I can adjust. I can put symbols. I have full control over now on how I use and work with this information. So recap: ingest raw data, process that information, push it back out as a stream service, and then use and configure a web map to now visualize and work with that information. And if I click on any one of these dots, we'll see all the information that's attached to that stream. And I could use any piece of this information to analyze or visualize or filter on, right, or create my dashboards from. Okay, a lot went on right there. Let's jump back to the PowerPoint and review. Configure the input, configure the output, connect the two together through a GeoEvent service. And if I need to do any processing, that's where I do it. Then configure my web map, publish, save it out, and share it with my organization. Okay. That's sort of an example of things that already exist, feeds that you get from existing services. And most AVL feeds come in that fashion. What about sensor data, right? Getting observation data from a sensor. So I want to kind of show you this. I'm not going to go through step by step because it takes a little bit longer, but I want to show you each component individually and how this works. So I'm going to start off with an ultrasonic sensor. I'm going to configure that sensor to communicate over Wi-Fi. I'm going to then do the exact same things. I'm going to configure an input connector and create some output connectors for visualization. So my steps here are going to be configure my input, configure my sensor to push data to that input, configure my outputs, connect the dots through a GeoEvent service. But this one, I want to take it a little step further. I want to configure my web map and then configure a dashboard to also consume that. Okay, so what I'm doing here, this is what the sensor looks like. It's literally sitting on my desk right now. It's attached to, it's an ultrasonic sensor attached to a Raspberry Pi Zero, which gives me the ability to push information over Wi-Fi. But what's really important here is I'm using an onboard flow-based programming environment called Node-RED. Now, you may have heard the term edge processing. So this gives me the ability to, at the edge, at the sensor itself, collect information, do some things with it before I even send it off to GeoEvent. And we do that through Node-RED. Those who are familiar with this environment, it's built off of the Node.js platform. So let's come back over here and kind of show you that process. So right here, this is Node-RED. I don't want to go into Node-RED per se, but I wanted to show you, I am actually connected to the sensor itself right now, sitting on that Raspberry Pi, and this is Node-RED, and much like GeoEvent, it allows me to drag and drop my inputs, my outputs, and my processing. So in this example, I attached my sensor to 2 pins on my Raspberry Pi and said communicate over those pins. I'm grabbing the data, very simple. I'm grabbing the data, attaching a unique ID to it. So I'm going to get a value for the ultrasonic sensor, attaching a unique ID, passing that data, and then I'm pushing it directly to a input connector sitting on GeoEvent server. Okay, very straightforward. If we look at the debugging window here side Node-RED, you can see the data that is currently flowing. And if I open that up, you see the value. So it's currently 116 unique ID. And that's what I need, right? I need that value. I need that unique ID. In this case, I don't have a lat long, but that's okay. I'm going to show you how to work with that. And I don't have a timestamp yet on this. So let's go back to my GeoEvent and let's go to my GeoEvent services and let's look at that particular process. So I'm going to go right here to my monitor tab under my GeoEvent services. Here's my ultrasonic sensor stream gauge service sensor built together. So this is going to give you an example of what I did for this sensor. Here's my WebSocket that I'm reading data in. So from the sensor itself, this is where it's pushing all that data to. When I get that data, I'm validating that I got the data, just an ID and the value of the sensor. And here's where I'm calculating the time. So in real time, I'm updating the data itself with a timestamp as I receive it. And when I get it, then I push it right back out to a WebSocket for testing. Again, this is for my benefit to make sure it's working. And then I immediately push it into a feature service. This is a hosted feature service sitting inside of the ArcGIS Enterprise platform, which then gives me the ability to display that. So I've established a location, a point feature where that sensor is positioned out in my field, my bridges, and I'm updating that information every few seconds of the data that's coming through that sensor. I'm also doing a process. So this is where I'm introducing the processing capabilities of GeoEvent. Here, I'm saying if that value gets below a certain number, meaning that water is getting too close to the bottom of that bridge, do something automatically. I want to send an email alert to people, but I also want to update my work order management system to automatically kick off a service request. So you can push out as many outputs as you want to based on the information that's coming in and how you're processing that data. All right, so let's take a look and see how this works. So here's the WebSocket endpoint for that. I'm going to connect to it real quick, and you can see there's the unique ID and the value coming over and the timestamp. Okay, so that's important. So now I got three things that are attached to that piece of information. If I go over to my web map, you can see here's my point feature class, one point that is taking the data in real time and storing the value of the sensor and the timestamp. You'll see it update every 5 seconds. So if I click on this, you'll see the information update every 5 seconds or 10 seconds, however often you want to configure that. Okay. So then the final step is once I got my web map configured, the data is coming in, then I can create my dashboards. So here's the dashboard of showing that I showed you earlier on. This is the stream, the ultrasonic sensor figure. And if I move the sensor right now, I'm going to take it and move it so it's pointing in a different direction. So you should see that update. So you see the gauge update. You'll see the map update based on the symbology coming in because I've used that value to symbolize the data itself. And then the final piece of that is the notification. So right now, if I take and put my hand over the sensor, it should jump down into the red, okay, which it did. So it fell below that 10. Right? It's at the 6 point. So now there's some things happening. GeoEvent is kicking off some things to take place. One of those things it did is over here in CityWorks, which is the work order management system that I chose to use. It's going to kick off a service request for me, push that over here, and allow me to see that data and as it's coming in. So let me give it a second here to update. I should also have gotten an email alert to tell me that, hey, things are happening. The threshold of that sensor has met its match. That things are starting to take place. Service requests are being generated, and I need to react against that database here. So a lot of things are happening here with this. Let me kind of recap again. We did an input connector. We configured the sensor to push information to GeoEvent, grab that information, do some analytical things, check to see if it's below or above a certain threshold, and then push information out, push it out to an existing point feature class that updates the information, push it to an email, push it to a work order management system out there. So you just saw this concept that we like to call work order or WorkSmarter integration, where we identify our sensors, we configure and integrate that sensor into the ArcGIS platform through GeoEvent, and then we configure that information to communicate to an asset management system or a work order management system or other business systems that you may need to push that information to. Maybe you're getting alerts from building management systems and you want to push out those alerts and create service requests in your particular work order management system. GeoEvent is capable of doing that. So let's kind of bring this all together now. So we know that we live in this connected world, and GeoEvent gives us the ability to bring that connected data, a connected environment into the platform, the ArcGIS platform. It allows us to visualize, store, analyze, react upon that information. And we're seeing these capabilities across the board. We're seeing them in our smart homes, the things that we wear, our vehicles, our communities, lots of spaces out there that are embracing the whole Internet of Things. They're embracing sensor technology, and they're using these new devices and the data that's driven from these devices to work smarter. Right? You've heard the term smart this and smart that. Well, it's all about the data, and it's data driven, and we can use GeoEvent to help us bridge the gap between those things that are out in space to the things that we need to use to work that event, whatever it may be. So how do you get started, right? How do we get into this space here? So a couple questions. First off, do I have ArcGIS Enterprise, right? That's where we start with this. GeoEvent is an additional server role component that plugs right into the enterprise platform and allows us to create that IoT tier, that enterprise IoT tier. Do you have the infrastructure to run GeoEvent, right? Is this on-prem or in the cloud? The platform is supported in both places, but we do recommend that you isolate GeoEvent from your other deployment components so that you can scale that out independently based on the amount of information and data that's coming through. Also, Have you identified some use cases? Are there some ways that you want to use this, or enhance the way you use and collect this information? Things like bringing in Waze data, or Verizon fleet management data, or asset tracking of devices and things like that, or doing real-time vehicle tracking of AVL, or take this WorkSmarter concept and bring sensor information in and react to that and kick off other things from that information. Let the data drive the activity. And then probably most important, what security concerns does your organization have in regards to, how do we encrypt that data from these feeds, these sensors, these signals that are pushing off information? How do we encrypt that, de-encrypt that? Do we have to apply HIPAA standards or FISMA or other type of standards to this platform, which the ArcGIS fully supports? All right, these security protocols. It really depends on your organization and how you want to implement the security. At what point do you want to do it at the edge? Do you want to do it at the sensor? Do you want to limit the type of data that comes through? Do you want to decode or encrypt that data as it comes across? There's lots of ways to make sure that we secure the information that's coming through these devices. So where can I might use GeoEvent, and what are some of the use cases? I've listed out here a handful of ones that we've seen some of our customers implement. Esri's been implementing these. We've had lots of good discussions around them. So, asset tracking, smart parking. You kind of read through some of these. One that sticks out to me was we have organizations and cities and municipalities that come to us and say, we have to empty our trash containers on a regular basis, but we don't really know if they're full or not. Well, a simple sensor to track the capacity of a trash container can tell me when to go out and dump it, instead of just sending a crew out there and just checking to see if it needs to be done. But catch basin cleaning, all the road conditions that we talked about, your skater world, looking at the utilities space of this. We had a customer ask us to track their voting containers, put a little GPS puck on these metal containers that have all the laptops and printers and voting equipment in there, so they know when they've been dispatched, where they've been, make sure they're at the right place at the right time. Those kinds of things. Food truck monitoring. Again, it goes on the different capabilities and options that you have to implement this technology, which will help reduce the waste, loss, and cost that you get from just randomly sending people out to do things. Let the data drive the activity, or at least invoke the activity response or the action required to go then take the appropriate actions to kind of fulfill the event, whatever it might be. So let me pause here just for a quick second, and let's have Shannon ask another question before we go into the final here of the presentation. Go ahead, Shannon.
Thanks, Steve. Yeah, we just wanted to ask, are you interested in learning more information regarding GeoEvent? This is our first webinar on GeoEvent, and we're putting together some collateral follow-up, so it'd be great to know from this audience, what are your thoughts?
So I remember the original polling question. We had some folks that have GeoEvent but aren't quite using it yet. Maybe just need some guidance on how to best configure it, set it up, get some initial data in. That'd be a great way for GeoEvent to help jumpstart you in this process. And we have some really nice jumpstart packages to help get you up and running very quickly there. So as I expected, yes, quite a few of you are interested in more about this. So we'd love to talk with you further on how to get the best out of your GeoEvent investment there. So let's move on. Let's go into any questions that might be out there, Shannon, that you might be able to pass my way.
Yeah, we have quite a bit on this one. Is it possible to have GeoEvent activate a scheduled task on the server after it has been noticed that data in a SQL database has been changed or added?
Yeah, so that's basically what we call a trigger. So GeoEvent can listen to information, and much like the way I explained what David's doing over in Roanoke with PSAP, it's listening to a hosted feature service or feature table service listening for changes. If a value changes or the status changes, react to that change and then push out a notification or push out data to another service or call another application through a REST endpoint, like I showed with the example of sending data to an Azure type of IoT device. So yes, GeoEvent can be used to listen to data in one space and then react or kick off and trigger events in another space.
All right, next question. Are SMS notifications handled natively, or do you need an external system to send the actual SMS?
Natively. You just need to have the right credentials so that you have permissions to send those and the right protocol.
All right. Another wants to know, what is a WebSocket?
A WebSocket. A WebSocket is basically the ability to open up the internet, the web world, so I can listen to real-time information. So as data is being pushed, for instance, that ultrasonic sensor is pushing data out every 5 seconds. So a WebSocket allows me to open up a connection between GeoEvent and that sensor and just listen for information. So I can either listen or I can push through a WebSocket on a regular basis.
Do you have a demo on how you would use this workflow for wearable devices?
For wearable devices, I do. And in fact, I think I even have it on standby because I thought that might come up. Let me go back to my browser here and jump over here to this website. So here, you're looking at the Birmingham office, GIS Inc.'s Birmingham office, where we're tracking wearable devices. It could be a smartphone that we're wearing on the side. It could be a Wi-Fi enabled anything. It could be Bluetooth. It could be RFID. Here's an example of tracking those devices inside. So anything moving, and this is basically employees and stuff in our Birmingham office right now, tracking those things. And it could be the smartwatch sending a signal to the smartphone. It could be Bluetooth. It could be we have several technologies built into our demo lab here that illustrate that wearable concept.
What other ways are there to process the raw data from sensors before ingesting into GeoEvent?
So some of the things we've seen over the years in this space is that sometimes we get a lot of noise. And we want to filter that data out before we push it into GeoEvent. Right? We only want the relative information coming into GeoEvent, okay? Especially if we have lots and lots of data. We don't want to overthrow GeoEvent with all this data. So in the case of the node red that I showed you, I may want to process that data before I even send it to GeoEvent. And maybe I'm only sending status changes, or maybe I'm filtering out MAC addresses of smartphones or wireless devices. So I'm only getting smartphones instead of laptops and projectors and other things. Or maybe I want to pre-process that data to clean it up a little bit more, to standardize an address or to standardize an output. So there's those kinds of things you can do ahead of the game before you push it into GeoEvent.
Have you dynamically imported geofences such as watches and warnings and performed intersection on a facility?
I have not done that in real time. I usually create my geofences ahead of time and put them in place. So no, I haven't done that myself yet, but it's definitely possible.
From Pi core site, can we consume a JSON service, or should we use the Pi integrator for ArcGIS?
Probably either. I know the Pi integrator works very nicely with the platform, but you have options there. So I think it'd be nice to look at the use case and figure out what would be the best approach, because there's something else that we found out over time is that there's really not just one answer for every kind of request, protocol, piece of information. Everything's a little bit different. So it'd be nice to kind of see the data as it's coming in and kind of pick the best way to ingest that. But Pi integrator works very well.
Is there a list of sensors that are compatible with Esri GeoEvent Server?
So I don't think we need to think of it from a list of sensors that are compatible. Think of it from a list of protocols, right? Things like pulling a URL for JSON or GeoJSON or a REST endpoint, or because there's so many sensors out there, and we've seen this over time. So we try to narrow down to the actual communication protocol. And if you remember when I brought up the GeoEvent website and showed you all those different types of connectors, there's quite a few out of the box connectors that allow us to connect to just about any kind of protocol out there. The ones that don't exist yet can be easily done. Like the sensor one that I just showed you, the ultrasonic sensor one, that's out of the box, didn't have an input connector, but I created a JSON component out of that data and then pushed it to the WebSocket inside. So typically a WebSocket or JSON feed, those are the common protocols. So don't think it from a sensor standpoint, think of how that data is being communicated from the sensor out. And so usually it's a common API or a common REST endpoint.
Right, a few more. Is Node-RED based as a subscription service?
So Node-RED is open technology built on top of Node.js. We use it a lot, and we see some benefit in it at the edge, processing information at the edge on the sensor itself or on the device that we're working with. So it's an open technology, and it works very nicely, and it has a lot of IoT components that plug right into that platform that allow us to gather data at the edge again, right at that sensor level, and then push it into the platform.
And then can you show how to calculate time received using the field calculator?
Yeah, let me jump back there real quick to my platform, and here. So all I'm doing is I'm using the out of the box. So this is just a function that comes with a GeoEvent that says receive time, and I'm going to store that in a field in my Geo database called receive time. And as that data comes in, I just do a quick field calculator, and push the result into that field.
Excellent. Yep, I think that's all we can take for now. We're about almost to the top of the hour, so we'll go ahead and close. So everyone, by next week, you'll receive an email with this webinar's episode recording link. As a reminder, there's going to be just a few short survey questions that come up once I finish speaking, and we greatly appreciate you taking your time to answer them. Thank you so much, Steve, for presenting this great information, and thank you all for joining us. And please have a great rest of your day.
Yep, thank you, Shannon.